Good evening. This is meteorologist DT with the video podcast for uh, Wednesday, December 20th. It's 8:15 in the East Coast. We'll talk about a lot of different winter weather here potentially on the Snowstorm podcast. So let's get right to it. Our topics will include the Christmas Day snowstorm for the Northeast, the snow risk. Really, it's going to be mostly for the interior portions of the Northeast. The evolution of the overall pattern, the December 28th snow and ice event for the Mid-Atlantic, and a moderate snow for southern New England, and then the risk or possibility of a significant or if not major winter storm on December 30th, which we can call the big dog. All right, let's get started here. These are the different alert conditions on the snowstorm alert table, and you can see, the pink means no snowstorm threat, the green is minor snowfall, but not moderate or significant. The blue is a moderate snowfall. The yellow is a significant snowfall, possible but not certain. The orange is a significant snowstorm is likely, which could be upgraded to major. And of course, the condition red is a major snowstorm, historic, likely, maybe even historic. So, and right now, this is my latest here on December 21st to the 23rd, and then December 24th to the 26th, and December 27th to 28th. So you can see I've got in the Ohio Valley Midwest the condition green, which if you recall is a minor snowfall. And then the interior Northeast, day 4, 5, and 6, I've got a significant snowstorm there. The two different snow events, we'll get into that. And then on the 7, 8, and 9 for I-95, you can see condition orange, which is a major snowfall. And that interior Northeast, decent snow there as well, and also for the Midwest. So let's get right to it. Now, the ideal teleconnection or setup for that greatly increases the chances of a big East Coast snowstorm pattern is to have the Eastern Pacific Oscillation in the negative phase, the P&A to be in the positive phase, and then on the East Coast, on the eastern half of North America, you want the Arctic Oscillation to be in the negative phase, and then the NAO to be in the negative phase, and you want to have a 50-50 low over southeastern Canada. So we'll get into those in a minute. Just stand by. I'll show you how this all works in a minute. Now, these are different forecast models for these different teleconnections or specific atmospheric weather patterns. The EPO, the East Pacific Oscillation, as you can see, it's strongly negative until January 1st, and then it goes slightly positive. So that's pretty good. The P&A is negative. That sucks. It's not good till December 30th. It's actually the wrong phase for an East Coast storm. And the NAO really sucks. It's strongly positive right through. So you're thinking, okay, well, that's bad for snowstorms. And if we look at the teleconnections here from Weather Bell, you can see the European Ensemble Arctic Oscillation is consistently positive, both the operational and the ensemble mean. So you can see there's the ensemble, the green, strongly positive all the way through to the end of the month. Okay, well, we know that. That's not good. And here is the NAO, which is also dips down briefly negative on Christmas Day, and then the rest of the time frame it's either neutral or positive. So again, like, okay, if that's what you need, if this is what you need to get a snowstorm, we're not getting any of those things except for the Eastern Pacific Oscillation. So that's bad. Well, maybe not. In the weather business, when you're forecasting snowstorms, there's a very important feature known in the weather business that allows snowstorms to form and increases the chances of it happening. And this atmospheric feature, which you can see right here, this is referred to as the 50-50 low. 50-50 low. Why do we call it that? Because it's 50 degrees north longitude and 50 degrees north latitude, or it's often referred to as a NF or Newfoundland low because of Nova Scotia and Newfoundland, Canada. This low keeps the high. See the high here? This is the Arctic high. Okay, so what happens is this low here over southeastern Canada keeps the Arctic high right here trapped in place. So the winds stay out of the north and the low pressure areas stay to the south. They don't come up into Michigan or Ohio. They stay way to the south and they become coastal storms. That's why this 50-50 low is so important. So again, the 50-50 low in southeastern Canada does two things. It keeps the Arctic high in place. So the cold air stays in place over the Great Lakes and it stays cold over the Tennessee Valley, the Ohio Valley, the Mid-Atlantic, and New England. Second, it forces the low coming out of Texas and Louisiana to stay to the south, either coming up from the southeast U.S. coast or it reforms off the Mid-Atlantic coast. So that's what the 50-50 low does. Now let's talk about Christmas Day here. A lot of people are all excited about the Christmas snowstorm in the Northeast. I don't see it. Not for the coastal areas. Now, this is the European model here, and we can see the red line. This is the 0850 line. This is the rain snow line. And you can see Christmas morning, it's way to the north. It's almost like Albany. So this is all rain here in New York City, LaGuardia, New Jersey. It's rain probably in Philly, or ending as drizzle. And then even to look at this, it's on the North Carolina border. In Connecticut, sorry, North Carolina, northern Connecticut border. It's even got the rain snow line north of Boston on Christmas morning. Now this is the European. It takes the low, as you can see, over New York City and then into Connecticut. And this is all snow in here, but the coastal areas, this is all rain. Now, all right, if you look at the European ensemble, the low is further off the coast, which is true. And this is more snow for New York City, Connecticut, Boston, Rhode Island. Okay, that's fine. The problem here is that if you look at the surface temperatures, there's low level temperatures are still too warm. 38 degrees in New York City, that's not accumulating snow. 32 Bradley, maybe. 34 Providence, Rhode Island, that's not accumulating snow. Bridgeport 36, Philadelphia 38. So this is mostly either a snow rain mix or, rain. So, and if we have a wet ground, you're not going to see accumulating snow there. Now, inland, it is going to be a significant snow. For example, you can see here how the European handles the system. There's the snow on early 1 o'clock in the morning, Christmas Day. The blue is the snow, in case you don't know that, okay? So this is snow. Just point this out to you. There's the snow here. This is all snow, okay, the blue stuff here. And this pink stuff, this is all ice, and the green stuff is rain. So you can see this is 7 a.m. on Christmas morning. The rain, New York City. Rain, mostly Connecticut. Rain, eastern Massachusetts. The snow is well inland, north central Pennsylvania, most of interior New York State, and interior New England. And then by 1 o'clock on Christmas Day, it's still raining in Boston. Hasn't gone over. Here's the snow amounts. This is from the first low on December 23rd, when everybody else is getting rain on the East Coast and warm temperatures. The first low comes by, brings you, 2 to 8 inches of snow over northern New York State, interior Vermont, New Hampshire. The second system, this is the one Christmas Day, you can see the accumulating snow here. And then finally, December 25th, there it is. And again, so these two events, you can see Christmas Eve and then Christmas Day. So it's a pretty good snowfall. Total over upstate New York, interior Vermont, New Hampshire, interior Maine. Now, the GFS is much worse. You're thinking, well, what about the GFS? Maybe it's got, no, it doesn't. This is the 18Z GFS, and the low is way off the coast. It's nothing going on here Christmas morning. Nothing. So, if you're counting on anything, you got to count the European, and that's pretty warm, relatively warm on the coast, and it's rain. Even the GFS ensembles, way off the coast at 18Z. Nothing going on at all Christmas morning or Christmas afternoon. So, even for December 25th, less than 5 days away, the 12Z and the 18Z GFS is vastly different from the European. Now, the Xmas Day low, on Christmas Day, that goes up in the southeastern Canada, where it stalls and becomes a 50-50 low, and this sets up the pattern for December 30th and the possible big East Coast snowstorm. Now, this is the European model for day 7. There's our 50-50 low. Let me highlight it so you can see exactly what I'm talking about. I think I have. You see the blue area? That's the 50-50 low. Now, here's the next piece of energy right here. This is going to swing south like this and become a coastal storm of some type. That's what the data is showing. Look at our temperatures. Now, this is the day after Christmas. Notice that the Arctic air, for the most part, stays over Minnesota, Wisconsin, northern Great Lakes, and northern New England. This is the day after Christmas, December 26th. It's cold. Very cold in New England and the Great Lakes, Ohio Valley. This is December 27th. Now, with the snow on the ground in New England, you see a lot of temperatures of -10, -15 over New York State, Vermont, New Hampshire, so on and so forth. This is December 28th. The cold retreats a little bit, and then the cold comes back again on the 28th and 29th. So, a lot of cold air coming in here, but the Arctic air does not come plunging southward. Now, let's talk about the first event, December 28th. Here it comes on the European. This is Wednesday night, December 27th. Here's the Arctic high. Right here, you can see it. Cold air damming is right down the coast. Very strong cold air damming. The cold air is wrapping in this way. Here's the precipitation. And the next one, this is the morning of the 28th. And we've got the high is still in place here, keeping the cold air in place. We have a weak low here, and we have a front going like this to another low here and like this. So this is snow and ice for the most part. Not a big deal, but a little one. And you can see what it looks like. This is from pivotal weather. You can see a little wave off the coast here, a little tiny area of low pressure right here. Not a big one, and then perhaps another wave developing here and another one developing here. So there's your high, keeping the cold air in place. And here's our 50-50 low, keeping the high trapped. You see how it works? Isn't that cool? All right. And this is the European ensemble, also valid for the 28th. And we can see, again, a weak disturbance here, not a big system, a little weak low here. Here's the Arctic high, the Arctic air mass. There's our huge 50-50 low right over here. You can see that. And it's keeping the cold air in place. So you get a little bit of overrunning, some snow, some ice. This is what it looks like on the European on the evening of the 27th. And then you get a lot of ice in central Virginia, folks. This could be an ice storm for a lot of people up into D.C., then snow up in northern Maryland into Pennsylvania. And then this here is the total snow for the event for the 27th into the 28th. And you can see it's a decent little snow. It's not a big deal. And a lot of this right here in central Virginia, like I said, folks, a lot of this is ice in here. So there you go. Keep that in mind. Now, what about let me go back and show you. I didn't skip anything. Okay. The December 30th possible big dog, the big event. No, I am not fixating on the European model or just one model. There are many other features here that support this idea of something significant happening. Besides the European, we have the European ensembles for the past 3 days. The MJO, the Maddie and Julian oscillation, is in phase 8 in La Nina in December, which often supports a snowstorm on the East Coast. And we also have the Bering Sea rule as well. Here's the system coming out of the deep south. This is on the 29th. Now let's take a look. Up here is our high. You can see it there, very powerful. All right, another one here. And there's the low. You see it right here. So we have an inverted trough and another low forming here on the coast. Strong northeast, cold air damming on the coast. So we're getting rain and then heavy snow and ice just to the north. Arkansas is getting crushed. Tennessee is getting crushed. Kentucky's getting crushed. And then eastern Tennessee probably getting ice at this point. Now this is the 30th. Look at this baby. There's the low here. The second low is here. We have the Arctic high is here, keeping the cold air in place. This is a pretty big event, folks, potentially. This is what it looks like in pivotal weather. Just with all the, you can't see the precipitation. We take that off. This is what it looks like. So again, notice these are not gigantic low pressure areas. Okay, so you're not going to see a lot of warm air overriding the cold air in terms of at the surface. You're not going to see that. A weak low here and another fairly weak low there. Big, strong high here, keeping the cold air in place. A lot of cold air damming. This is the European ensemble. And again, you can clearly see the inverted trough right into this whole area. And another one here, another trough here, another trough here. And of course, here's our 50-50 low, the big storm up here, and the high is in place over eastern Canada, keeping the cold air in place. So there's another piece of information for you. What does this look like? Here comes the snow. This is early on the morning of the 30th, from the 29th to the 30th. That's a lot of snow, that dark purple, a lot of ice on the North Carolina border. Look at that on the morning of the 30th. Good googly moogly. What does this look like in snow amounts? Well, the Weather Bell site with its ridiculously enhanced snow amounts, I mean, this is just pathetic, but it gets everybody excited. I have to talk about it. Yes, I know it's got 22 inches in and around Richmond. That's bullshit. Okay? It's got 19 inches over Roanoke and so on and so forth. This is all enhanced because this measures sleet as snow, and it's, of course, sleet is not snow. The folks here from EuroWeather, much better snow algorithm, still shows a major snowstorm in central Virginia, 11 inches in Richmond, 16 out by Roanoke, and then more up into here as the snow continues up beyond that way. So this is just the beginning of the event. So again, I just want to show you what the snow maps are looking like because people are going to be talking about them. This is the European ensemble. Look how many members are showing the low off the coast. Strong support for this idea. This is not just one model. Now, this is the GFS, which let me show you why it's a piece of shit. Okay, it's the 18Z GFS. Notice what it's doing here. First of all, it's dropping all the energy here, Why does that? I have no idea. It just does it. The model loves to overphase systems because of the cold bias. It takes one piece of energy, it slams it into another one, and you get a big trough. And of course, now you've got snow. It actually has the rain line into Chicago, if you can believe this. And it's all warm over the deep south and mid-Atlantic states. And it does that because of this enormous ridge here. Now, this is not correct. And you can see it's not correct by taking a look at the GFS ensemble. Totally different upper air map. Let's take a look. That versus that. Whenever you have the ensemble not supporting the operational run, that means the operational run is crap and you should ignore it. So there you go. There's a pro tip for you. And of course, if you look at the GFS ensemble mean, again, totally different pattern. There you go. That's the video podcast. This is meteorologist DT. We'll play this through and see how it works over the next couple of days. I'll catch you on the Facebook page and on the Twitter page.